Hello, everybody. I just want to do a quick sound check before we start. Ed, are you there?
Yes, I am.
Okay, great. Hello, everybody, and welcome to the Sustainable Materials Management webinar series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Wayne Bowen. I'm the program manager for the Recycling Market Center and will serve as your moderator today. Before we get started with the presentation, we would like to extend a special thanks to Bob Hollis of the Mobius Network for providing the webinar management software for this series. The focus of today's webinar is on a new and innovative product made from mixed recycled plastics. Our presenter today is Ed Grieser, who I will introduce in a moment. Following his presentation, we will conduct a question and answer session. If you have a question or comment, please use the GoToWebinar dialog box located in the control panel on your screen. You may also use the dialog box to request assistance if you're experiencing technical difficulties during the webinar. Please note that an edited version of this webinar will be made available for viewing via YouTube links on both the National Recycling Coalition and Pennsylvania Recycling Market Center websites. The presentation slides will also be made available via a Box account at a later date. Stay tuned for your look at your email for future updates on that handout. And now I'd like to introduce our presenter. Ed Grieser is the CEO and founder of Hydroblox Technologies, Inc., which is located in Pittsburgh, Pennsylvania. At Hydroblox, Ed developed the manufacturing equipment and process to work with virtually any plastic to make a construction and drainage product that is superior to the traditional items and methods Hydroblox replaces. Hydroblox is now shipped worldwide and is being used for everything from green roofing to drainage solutions for residential and commercial development, for railroads, and the petroleum development industry. Ed began his career at Federated Investors, developing portfolio management software for investment research. He then moved from solving problems for finance to solving problems for water control. This was in the form of handling market development for a startup company and then an international company that manufactured ductile iron castings designed to reduce the amount of groundwater to sanitary sewer systems. Mr. Grieser is a graduate of Penn State University with degrees in economics and finance, and he resides in Pittsburgh with his family. And now I'm going to turn the program over to Ed.
Thank you. And thanks for taking the time to listen and hopefully watch today. I apologize in advance. I don't have much of a voice, but I'll do the best I can. Okay, Hydroblox, as you can see on the screen, is without a doubt the ugliest and least sexy product on the market, but it does have its special virtue in the fact that it is made from all recycled material, and it does a much better job of controlling water than the products that it replaces. We have a short video that runs here right now, and this is at the end of our production line, where when Hydroblox leaves our equipment, it comes out at just around 400 degrees. So it is clean, it is sterile, it doesn't leach any BPAs. It is fine. You can typically get it in any color you would like as long as it's black. And as a last step, part of our QA, we cool the material down and we check for water flow. So what you can see there are two water jets that have, like as I mentioned, are taking down the temperature of the product. And what you'll see is how quickly that water passes through that board. In that plane, it moves water at just a little under 40 gallons a minute a square foot. In a vertical plane, it moves it at 14.25 gallons a minute per meter. And the most relevant point about that figure is that's faster than any soil can perk water to it. So we have removed that as a design consideration. So take a look on the screen and you'll see the water just running through there basically just as fast as it hits it. It passes right through that board. Okay. Before we get to the part that you really want to know, which is how we can use all of the recycled plastic that you're generating, the way this works and the reason that it is superior is Hydroblox is a Tergazzi filter. So basically it's a GL textile that conveys water. Our weave, when we put all those noodles together, makes it tight enough that the larger fines don't go through. The smaller ones, which are 5 microns in diameter and smaller, just pass right through. So it doesn't clog. We've been doing this for 12 years and we've never had a failure. Okay. We did run into a client, at that time it was an inquiry, it was a client that wasn't quite sure that we were telling the truth. So what you can see where the arrow is, that brown mix is actually, that is the clay part of a professional baseball league field, the diamond. That clay basically becomes as hard as concrete. And the groundkeeper that was involved was confident that Hydroblox would fail after a short period of time. So what he did was, if you notice where the brown stops and then it goes to the black, now that's actually a plank of Hydroblox. They created this giant aquarium around it out of plexiglass. They poked a hole in the bottom of it, and what they did was they recirculated that water for 4 months, which simulated 16 years of actual use. And as you can see, it didn't clog up. And the reason the water is a little bit cloudy is those are the fines that are 5 microns and smaller that I mentioned earlier that just pass right through the board. There just isn't enough mass right there for them to stay inside the board. And then, you know, again, we've done what we said, we'd convey the water without clogging. This, as part of some of our testing, we've had this multiple third-party testing labs have looked at Hydroblox, and we've done it on both sides of the Atlantic. And this is actually just a side shot of what it looks like inside that Hydroblox board. As you can see, there are multiple redundant pathways for the water to make its way through the board. Okay. We had a customer that really couldn't get their head around the way things work. So what they did was they took a piece of Hydroblox, wrapped it in plastic, stuck it in a garbage can, and then just filled it with water. And as you can see, the water ran through the board and just dropped out the bottom. If they didn't have that plastic around the entire board, the water would just gone everywhere. Okay. Just very quickly, this would be the use for Hydroblox that most people would understand. I'm sure just about everybody knows what a French drain is. It's a trench with geotextile lining it, with perforated pipe in the bottom and aggregate all around it. Well, the problem with that is gravity, and things settle. The last thing you do when you put that installation of that French drain is you leave a little hump in the soil. And that's because eventually it's going to get wet and that soil is going to come down and it's going to compact and compress. And that's actually the start of failure, because those fines get in between the aggregates, and then water often doesn't get down into the French drain, the perforated pipe. The geotextile becomes clogged with fines, and eventually that perforated pipe does fill up with material. Well, with Hydroblox, the typical installation that most people are familiar with is a 2-inch wide trench, which is the same width as our board, about a foot deep. So you only go down a foot and you have about 3 inches of cover right on top of the board. You just use the spoil that you just dug out, you lay it down on top, and then you can reinstate. As you can see, it's relatively lightweight, and you just slide that piece of Hydroblox in the ground and off you go. Now, the way we developed the product in the market was probably the slowest, most expensive and tedious manner, but it was the most effective. And we did continuing education classes for engineers just about everywhere. And as a part of that, we were talking about how Hydroblox could be used to solve their drainage problems on both the residential and the commercial scale. And then at the end of that, as you can see on the screen right now, these were the specification drawings with generally a professional engineer's stamp on it. And these are typically the way that Hydroblox is installed. Again, it's just a much easier install. All right, and going backwards. There we go. So now that you know that, we have used Hydroblox for everything from filtering water. This is what it looked like before. You can see the water was cloudy. And then we created a different version of Hydroblox with a tighter weave, and then it filtered all the sediment out. And this is, again, a larger scale installation over in England. I believe this is over in Germany. Again, more of the same. Where the black boards that you see in the middle of the screen where the cursor is, that's Hydroblox, and all the water was directed through there. Okay, and then again on our industrial side, we're Pennsylvania-based corporation, and there is a tremendous amount of pipeline work being done up here right now. And what happens is if the hill is not reinstated and drained properly, what you'll typically find is what's on the right-hand side of the screen right there. Everything that's at the bottom of that hill, all of that soil should have been at the top of the hill. This is one particular installation where every other method to establish proper drainage in this slope was tried, and they had all failed. So at that point, the oil and gas industry really hadn't heard a lot about hydroblocks, and so we said, yes, we can handle this for you. So what we ended up doing at the toe of the slope, which is the bottom of the slope, there were 30 and 40 foot high walls of hydroblocks. And what that did was and you can see in the lower left-hand corner of that photo, you can see that they were backfilling on that without anything between the hydroblocks and the soil, just right away. And we went back 3 years later, and this is what on the left-hand side of the screen, this is the after, and you can see that absolutely nothing had moved. It's a very severe, very, very steep slope. It's from, the elevation is 1,500 feet and the run is about 2,000 feet. So, again, this is about as bad as you can get. It's very difficult to see, but in the upper right-hand corner, you can see a little bit of the hydroblock sticking out, and that's called daylighting, and that's where you bring the water out to the surface at the spot where you would like that to happen. But by daylighting it like that, you've pulled all the water out of the hill and you're directing to where it should be, which is into the creek or back into the aquifer. But the bottom line is the hill stays where it's supposed to be. Another application, which Wayne had a hand in, your moderator, was everyone is required to mitigate all of their stormwater. So what we have done was we have a much easier to work with updated version of a dry well, which is, as you can see in the diagram in the upper right-hand corner, we're connected in a large hollow box of hydroblocks to the rain conductors. What happens is you can add as many of these as is necessary, and the rainwater stays inside the hydroblocks box, that stormwater chamber, until the surrounding soil dries out to where it can accept the water, and then everything is as it should be. The water stays in the surrounding soil without overwhelming it, and when it can actually perk, it'll drop back down into the aquifer. And again, it's a very simple solution, but this is one that is, currently everybody's looking at solving. We're using everything, and now this is underground swimming, underneath and alongside in-ground swimming pools. This is underneath patio pavers. This is an application where it's just absolutely taken off. This is draining the water underneath railroads under their switch yards. And, again, this is a problem that's been, but as far as we've been told, it's unsolved for 52 years. And the installation that you can see on the right-hand side, this was the first time this particular switch yard had been dry in, as they said, 52 years. We have, again, the result of our learning lunches is people engineers bringing different ideas to us. And what you're seeing here is now the builders are using hydroblocks as the form for the poured concrete foundation. So you solve two problems at once. It's a much easier installation, and we're taking plastic that ultimately would be going to a landfill, and this is the way it's supposed to work. They use hydroblocks as again the water drainage medium for solar panel fields, utility scale. And again, just to give you an idea of why this has taken off, for the drainage cost for a 50-acre utility scale solar field would be about $2.1 million, and the complete installed cost for hydroblocks was $700,000. So it's a dramatic number. It makes everyone happy. The panels can be located closer together. There isn't the maintenance requirement that's associated with the other methods. You can see this here. And we are using Hydroblox now underneath porous pavement, both asphalt and concrete. We've had it tested. Even with the asphalt at the melt temp that goes in, it did not compromise the flow characteristics of Hydroblox. And again, it doesn't clog. This is an application for Hydroblox where it is the growth medium for hydroponic growth as well as green roofs. And as you can see in the top left-hand photo, there's nothing on there but grass. And because you can control every facet of that grow, we do get a higher yield with much less water. Hydroblox is a whole lot lighter, easier to work with for everyone. So that's a win-win. We have a customer list, international. Again, we've been around now for 12 years. And now we get to the important part, the reason for the call. We can divert this type of plastic to our manufacturing process. We can work with just about anything, but we do not work with PVC or ABS because of the fumes, and there's some products are just much easier to recycle in other directions. But typically, we take in everything, all of the olefins, PE, LDPE, ultra high molecular weight. Nothing is out of bounds there. We again shredded LDP plastic bags. Again, more polypropylene and polyethylene. You can see that it can be commingled. We can take in product that has paper on it. It can be wet. Again, here's PET that is, you can see it's been contaminated with labels and some polypropylene lids. Again, there's polyethylene. Typically, everything we work with is in regrind form. Okay, and again, more LDPE. But the point is, we can work with just about everything. What we don't work with, I'm sure that's going to disappoint everyone, is the 3 to 7 mix, as it turns out, is always much heavier with PET than what everybody would estimate. But again, our sweet spot is we can take up to about 8 to 10% contamination. Even with as long as there isn't metal in there, we've taken in wood chips, paper, the BOPP labels. We are fine with that. Here's an example of this is the boat wrap that goes around if you store your boat in the winter. This is that heavy LDPE that for whatever reason, because when the boats are unwrapped, it gets dragged through, across the grass, and then that creates a problem. Well, we're fine with that. Again, more different samples of the regrind that has come through our door. Here's a good mix of, just about everything. And, again, our position is we weren't making a green product just to make a green product. Truth of the matter is we were trying to make a buck. But as our development method has progressed, our facility has to be among the greenest out there. We don't exhaust dust. We don't even have floor drains. We use about 200 gallons of water per week, but that's only because the material is 400 degrees when it comes out, and it's released back into the atmosphere in the form of steam. Again, as I mentioned, we've had this tested over and over. No leaching of BOPP or anything. We came up with clean numbers. And I guess in closing, this is where we've sold product around the United States, just in the United States over the last 30 days. So we do know that this can be used, and there is a demand for it just about everywhere. So we're working on our second facility here in Pennsylvania, but we know right now, and this is what I'm busy, this is my task right now, to get other facilities set up in other parts of the country, because our view is, for example, it's the same as concrete. You don't ship concrete around. There's a batch plant where there's a need, where there's abundant raw material, and there's abundant, our feedstock is abundant, and it is just about everywhere. So what we're doing is we're matching up where the need is with the raw material. We also have something that we've talked about for probably 5 years now, and our first project is just about done. And as soon as this is completed, we're going to be able to publicize this. We have the green light, but we just want to make sure we make our first delivery back. So, you know, we're completely above board. We have an international company that is sending us their scrap that they were having a difficult time getting rid of. It's basically polyethylene. And what we're doing is returning to them that same plastic in the form of Hydroblox. The company is certainly large enough where they would have a variety of uses for Hydroblox, whether it was just normal drainage around their facilities, or more accurately, this is going into the green roofs on top of their factories. So this is something that it's not as prevalent here in the States as it is over in Europe and in the UK, but there's just a huge push to be able to, for a company to be able to say, you know, we are doing 360-degree recycling. You know, it's not leaving the loop and it's coming back. It's something that's at a much greater value than the scrap that it was when it left our facility. Okay, well, I promised that I would be quick, and that's about this is about the end of it. We certainly have all sorts of we have test results, we have our MSDS shit, we have all of our spec drawings that would be available. And again, if you would have any questions, you know, please give us a call, give us a contact. I'll make sure that this presentation is uploaded as soon as we finish this. But other than that, I'll hand it back over to Wayne.
All right, thank you, Ed. Great presentation. So right now we're going to field some questions for Ed. If you do have a question or comment, please use the GoToWebinar dialog box. We do have a couple questions already here for Ed. This question asks, does Hydroblox have a third-party company to certify for the recycled content, for post-consumer recycled content?
No, we don't, but if it needs to be, that's just one thing on the list that we could certainly have happen.
Can you estimate how much of the product is post-consumer versus pre-consumer or industrial recycled content?
We're 80-20 scrap versus post-consumer.
Okay, so 20% post-consumer.
Yes, right.
Okay. And the question is, do you have a consistent supply of feedstock? I think that's an obvious answer, that you do have a constant supply.
Yes, but given what we said, we're always open to new suggestions.
Right. What's the average service life of Hydroblox? Do you accept materials from households?
Well, yes. You know, again, is it just you know, a 3 to?
Oh, Ed? Oh, we lost Ed there.
Nope. Still here?
Yes, we lost you there for a second. Okay, I'll repeat the question.
Oh. Okay.
What's the average service life of the Hydroblox?
Average service life, we've had our longest install, we're at 12 years.
Okay.
If that's
and
the question.
next question is, do you accept materials from households? So any, you know, like cans, you know, plastic bottles or rigid plastics from households?
Yes, we could take mixed rigid plastics, yes.
Okay. How about in the very hot climates? How does this material respond and perform?
There's no issue there at all. We have Hydroblox in Panama, down through there. And again, we've had it tested, and I think all of the testing that we did when we were binding to asphalt to it was, you know, that exceeds anything that we would find in any tropical climate. There was no issue.
Okay, I ask you this question all the time also. The question here is, when do you anticipate your second manufacturing facility to be online?
By the first quarter of next year.
Okay. And is number 6 usable? I believe that's polystyrene.
We just took in polystyrene, and it was polyethylene with, I think, about 3% polystyrene. So, you know, again, we would consider that a contaminant, and we try and keep that under the 8% threshold.
If you're comfortable sharing this figure, what is your annual capacity in tons to process post-consumer plastics?
Where we are right now?
Yeah.
Where we are right now, you know, we run through 80,000 pounds in 40 hours.
Wow.
So I'll let you do the math.
How does the product stand up to weight? Meaning, if it was used as a road covering, how does it stand up to this type of use?
As a road covering, that would not be a good idea, simply
Right.
because if you noticed it, as I mentioned, let me go back to something on there where you can hopefully, if you look at that board, you can see how there are openings, there are voids in there. That would be a trip and fall problem. I can't imagine anyone wanting to traffic on that. However, underneath the roadbed or underneath the aggregate or underneath the porous pavement, the compressive strength is 40,000 pounds a square foot. So that's twice H20 loading, which is what all of the castings are in the road. So we don't have any problem there. In fact, when the destructive testing was done, where they did actually just squash the hydroblocks, the only thing that happened was the deformation where the air was pushed out between the noodles, and then it did actually rebound.
Okay. Again, if you're not comfortable with this question, do you pay for your raw material?
Yes.
Okay. Has testing been done on leaching contaminants into the water and soil from these different plastics being used?
Yes, it has been. We have those results available.
And what is the likely mode of failure? Not sure what that means, but.
The likely mode of failure. Do you mean?
I would assume clogging or failure of.
The only time we've ever had a problem was where someone took clay and just used a tamper and packed it all the way around the board so no water could get through the clay to the board. So it wasn't that Hydroblox failed, but that would be a problem on the installation. So we didn't get into that here, but we're very clear that, you know, you just want to make sure you don't, there has to be a pathway for the water to get to the board.
Right. So if you install this in a clay soil for drainage, for example, you need to be careful when you backfill that excavation that it's not compacted so severely that it will not allow water to pass through it.
Right, yes, because if you're going to make a brick around it, which is basically what you can do with the clay, the water's not going to get through the brick to the board. So yeah, you've got to make sure the water can perk.
Okay. Maybe you can go back to this slide, but what this person wants to know, what's the purpose of the hydroblocks in the solar array construction?
Okay. All right, let me get to that. Okay. Right now, you have to control the water that it's not allowed to leave your property any faster now than before it was developed. I mean, that's the way things work. So let me just get to this. And okay, so what we have here, if you just take a step back and look at a solar panel, which is what you see, they look like tables there that are on a slant. That is a roof, a tiny little roof that doesn't have gutters. So what happens is the water comes off of that roof and it has velocity and certainly has mass. And what it does is it hits the ground and causes erosion, and then eventually will build up enough sheet flow where it'll leave that solar panel site. And that, actually Wayne can tell you more about this than I can, that's prohibited. The water has to be maintained on site. So what we did was we developed a method where they offset You can see where the end of the solar panel is. So they move 2 foot on the downhill side of the slope, and you can see they left 2 inches of it sticking up above grade. So what happens is the water comes off of that solar panel, hits the ground, hits the board, and then it follows the board out to the swales or wherever they would like the water to be directed. And that's just job done. And because that is so invasive, and there isn't the expense and the problem and the failure of the regular French drain system, the governing bodies have decided that, you know what, we don't have this maintenance problem and we don't need as much space. So they've been allowing the solar panel manufacturers to actually reduce the space between the 2 arrays. And so basically now you're getting more energy out of the same space, and you've solved the drainage at a cost that was about 1/3. And they haven't had the failure. This one that you're looking at was down in Garrett County, Maryland. And we put it in, and absolutely, it was the very first one going back, I guess, about 4 years now, and they've had 0 problems. And with everything else, you know, the problems are manifesting themselves by 2 years, by year 2 at the very latest. Okay.
And also, I want to add that I know, like in Pennsylvania, the requirement is to infiltrate a 2-year storm. So, you know, this particular installation probably would be designed to handle the 2-year storm. So some states might require 5 or 10, but the goal here is to infiltrate that water, not let it get off site at all, and have it go back into the ground on site versus running off into a water course. So next question is, what's your current production capacity per month in terms of linear foot of hydroblocks?
We can make a board every 7.5 foot board it's 51 seconds.
So again, do your math.
Yeah, there you go. Math is good.
Are you grinding / shredding yourself, or are you only able to accept scrap plastic in shredded or ground form?
We're doing both now.
Okay, your website mentions 4 different types of products: hydroplanks, hydrobase, Hydroblox Durafence, and Hydroblox filter box. How are they different in terms of design and application?
In terms of design, what they have are different flow rates. Those different applications require, you know, again, just some higher flow rates, others not as much. And for example, in the railroad application, that board is a little bit heavier and it is a little bit stronger. It's 45,000 pounds per square foot compressive strength. But, you know, again, the board is designed to fit the need. Our filtering boards, they, again, have a smaller noodle, a tighter weave to capture the fines. And for weaving, for our hydroponic applications, we have a board that is much lighter and has larger noodles with more void space for allow for better root structure.
Okay. Is Hydroblox available for purchase by the general public, or do you have to work through a distributor to obtain this material?
No, it is available. The one thing that I really did want to do, because all of our work up at this point had been commercial and, you know, professional contractors, and on our end, that was very easy. You have people that are absolutely used to working with things like this. You sit down, you explain it to them for about 15 minutes, and then they look at you, they get it, and then they take off. Okay, well, that's pretty much job done. What we did not want to do was retail. But True Value Hardware, they were the first ones. They approached us, and they just said, you know what, we'd love to do this. And I explained what my reservations were, and they said, we will handle all of that customer interaction. We'll hold their hands. We'll help them on design, explain to them how the way things work. And then what we had to communicate to them was the design is exactly the same. We would get those phone calls. How do I put this in the ground? You know, where do I put it in the ground? And our answer is, you're doing the very same thing you would have done with that other French drain. You're just putting something in the ground that isn't going to fail and is a much better conductor. So once we got that worked out, that's been very pleasant. So now Ace Hardware has they've come on board, and then there are other. I think Wayne, you're going to be happy. 12 new True Value stores in the eastern part of Pennsylvania as of this week. So that should make things easier there. But what we haven't done, and this is me being difficult, we were approached by the two big box stores, on the hardware side, and they were adamant that they, wanted Hydroblox inside their stores. And I said I politely declined, and they were a little confused. And I explained to them that I love your stores. I'm a customer myself, but there's a problem here. And I said, and I want to make sure I love the app that you have for your phone. When I want a toilet flange, I can just punch it in and I can find it. And both of the box stores were happy when I pointed this out. And I said, so that's great for that. But on my end, Hydroblox isn't intuitive. You're not going to look at it and go, oh my gosh, I know what to do with this. You're going to look at that and go, oh my gosh, that's ugly. How can they be selling this? And that's what we need. And then when I made the point to the box stores that they are moving in a direction of limited customer interaction, that would be failure for my product. And as far as they were concerned, it would just not work anywhere. So it is available for normal do-it-yourself work. We're adding distribution on there carefully, I would say, because if we're not going to do that right, why do it at all? We're going to just create more problems for ourselves. So that's coming along nicely. There's a contact form on our website. If you fill that out, it gets funneled off to the right people that can help you with that. And the most important part there is the people that you're going to be talking to know what they're doing, and they can guide you to it is a very simple product to use. But if some people have never done any work for themselves like that, and maybe you do need a hand. But yeah, so that's a long answer to a short question.
Okay, has your product been involved or used with any LEED certification buildings?
I know that it's been done, and we did try and go down the LEED path, and you know what? I'll tell you what, it just seemed to be a chase that we really never got anywhere with the certifications per se. But I know that it has been used in those buildings. But I'm certain they did not get the LEED credit that they probably should have. And I'll take the blame for that. But we just haven't really had a whole lot of luck with that organization.
Is there any concern with UV degradation with the Hydroblox that's left exposed, such as the ones that are in the solar field installation?
Yeah, we did have that testing done, and you do lose a little bit every year. It was out 3 decimal points. So the engineers involved just said, yes, okay, so it's not an issue.
Can you share the cost of the board? I guess you can tell what they charge at True Value.
Yeah, they are, I think they're around $9 a foot. I'm not sure, but I know the further it moves away from the factory, that number does creep up. So okay. Don't hold me to that one.
Okay.
And actually, the truth of the matter is that's largely borne by transportation costs. And right now, I'm certain most of the people on this conference have done any freight work right now, but it's absolutely through the roof.
Okay. All right, looks like we're out of questions. So I appreciate those questions from the audience. Really good questions and comments. So we're going to wrap it up right now. So this webinar, like all the webinars in this series, has been recorded and will be made available via YouTube links on both the National Recycling Coalition and Recycling Market Center websites. As I stated in the chat room, I am going to provide everybody a link to my Box account that will allow you to upload the presentation slides. So thanks again for joining us, and thank you, Ed, for taking the time out for this presentation. We hope you'll join us for next month's webinar, and please visit the NRC and RMC websites for schedule updates. And have a great day, everybody.
Okay, thank you.